In this lesson, we are going to be exploring the p-value method. And the p-value method is a way that we can do hypothesis testing, alternatively to using a rejection region. So we've seen examples where we have critical values that determine a rejection region. It's either to the right, the left, or on both sides of those critical values, depending on if it's a left, right, or two-tailed test. And then we would drop our test statistic into that region, or drop our test statistic in and see if it fell into the rejection region. The p-value method does not do that. The p-value is the tail area that is associated with the test statistic. So we will explain what that means in the three different scenarios that we could possibly have. It's possible that we have a left tail test. So I'm just going to make up an example. Let's say this is a left tail test for a population mean. And so let's just making up some number K and my hypotheses. And I know this is a left tail test because this inequality right here is pointing to the left. I'm also going to write up some inequalities for if I were doing a right tail test. So I would want my inequality in my alternative hypothesis to point to the right. And then say I were doing a two-tail test, my alternative hypothesis would have a not equal to it. So those are the three different scenarios, and let's look at them. Let's say that in the left tail test, we compute our test statistic and it lands right here. So there we have our test statistic. This is a left tail test, so I'm going to be looking, notice that it's not a critical value, that's the test statistic that we got using some formula. I'm going to shade the area to the left of that because it is a left tail test, and this area is our p-value. If we were working on a right tail test, let's say that our test statistic maybe landed somewhere over here. So that's the test statistic that we would have gotten from using some formula. Which formula we would use depends on the type of hypothesis test. We've seen three different types so far. Two for the mean, depending on whether population standard deviation is known or not, and one for a population proportion. So I shaded to the right of that test statistic because this was a right tail test. This right area over here would be our p-value, right area. P-value is short for probability value. And in a little bit, we'll talk about how we use that value to make a decision for our hypothesis test. And the last case is, let's say we had a two-tail test. So we had a two-tail test, we run our test, and we get a number for our test statistic. We're going to look at the positive value of that test statistic and the negative value of that test statistic. So they're the same number, it's just that one's positive and one's negative. So I've labeled them as negative test statistic and positive test statistic. Because this is a two-tailed test, I'm shading to the right of the positive test statistic and I'm shading to the left of the negative test statistic. Each one of those individual areas is half of the p-value. So the entire p-value is the sum of both areas. So this area combined with that area, that total area is the p-value. So one tail just gives you half the p-value, but when you put it together, you get the entire p-value. And we'll see examples of all three of these cases and how to work through them and make some decisions, which is the next thing that we're going to talk about. How do we use that p-value to decide whether we're going to reject the null hypothesis or whether we're going to fail to reject the null hypothesis?